Hello everybody, so today we're doing an LS430 2000 to 2003. That is a 3UZ-FE VVT-i, and in this case it is a manual gearbox for a right-hand drive vehicle. So let's get into it. Right, so as discussed, this is a LS430 2000-2003. That makes it a 3UZ-FE VVT-i that originally had the 5-speed auto at the back of it. This harness is designed for a right-hand drive vehicle for a manual gearbox. You'll see we've removed all of the automatic gearbox wiring, or we haven't bolted in for the new harness. We've also remapped the ECU, so obviously all the automatic gearbox codes are gone. We've also increased the throttle response, slight tweak in power. We've also got rid of the secondary Lambdas in the evap system, so you have 0 codes on the ECU, even though it is running a manual gearbox. Right, so we're going to do a few things today. First of all, we're going to do a couple of tests, go through the layout. We're going to have a running test and test with just the ignition on. But first thing we're going to do, we're going to cut through and show you guys what it looks like underneath all this heat shrink, the build process, and all the little sub harnesses that go along with this one. All right, so let's do that and we'll be back in a second. Right, so now you've seen what it looks like underneath there and with the build process and what we do with the harnesses and how they look. Okay, so as discussed, we're going to be doing a couple of things now. First thing we're going to be doing is going through the entire layout of the harness. So Jonathan, the customer, knows exactly where everything goes. Obviously, everything is labeled nicely on there, so you shouldn't have any issues in regards to fitting it. But we're going to go through the whole layout so he knows exactly where everything goes and where to put everything. Then what we're going to do is move on to the actual testing. So that's going to involve 2 sections, one with just the ignition on. We're going to test a couple of things, and then we're actually going to start the engine, get it running so you can hear nice and smooth, and then we'll carry out some tests while it's running to make sure everything is working exactly as we want it to. So what I'm going to do, first of all, as I said, go through the layout, and we're going to start right here at the ECU, and it's also going to involve going through the customer plugs so that the customer and anybody else in the harnesses knows exactly what's involved with fitting your side at the vehicle itself. All right, so at the ECU end, it's really nice and simple. You've got your 3 ECU plugs there. They go to the actual engine harness itself. We then have the 2 body ECU plugs. They go to the fuse box over there, and then we have all the powers and everything for the harness coming this side, going to the fuse box. So the fuse box controls everything either by itself or from commands from the ECU. In the fuse box, only 2 plugs that are relevant to the customer is basically these 2 over here. Now this one over here is not really super relevant because it's only got the OBD2 in, and that is just a hardwired thing so you guys can plug in an OBD2 machine, retrieve live data and trouble codes as well. Okay, so that's nice and simple. We do have 1 wire in there, which is your brake switch, so that requires 12 volts when you press the brakes. All right, this is your main plug over here. So this is the one that's going to get everything you need to get the vehicle started, and that's the one we're going to go through now. So obviously, Jonathan, you're going to receive all of this via email, so you'll have a copy of this to keep forever. The welcome pack does include the entire fuse box layout, what each relay is, what it does, all the fuses and their sizes as well. Okay, and we're going to go through that now. Okay, so looking at the 9-pin plug over here, and I remember all these plugs in the fuse box are completely unique, so you can't put the wrong one in the wrong slot, so you don't have to worry about that at all. What I'm going to do now is I'm going to move over to the sheet here because it's easy to explain, and you'll see the 2 wires that are missing that I've obviously put our wires into is your big red and your gray one over there. So we're going to go through now. I'll go through all the colors here and you'll see exactly how that equates to that plug over there. So pin number 1, that's your red one, so that's the red one that's over there. that is a permanent 12 volt supply. So you do need to connect that to a permanent 12 volt supply. The ECU does store all the diagnostic codes when there are errors. So if you connect that red wire to an ignition source, every time you turn off the key, you're going to reset the ECU, which is going to make diagnostics very difficult, if not impossible. So do remember, permanent 12 volt supply, not an ignition 12 volt supply. Next up, number 2 is a black with a yellow tracer. That is your start signal. So again, nice and simple. It just requires 12 volts. So you can either take that from the back of your key barrel if you have an ignition key barrel still in your vehicle. If you are doing a start button, one side of the start button has 12 volts, other side goes to our black with a yellow wire, and that will then activate the starter. Now, obviously the black and yellow wire you'll see is only a 20 gauge, 0.5 millimeters. It's just controlling a relay. That's not what's actually going to your starter motor to do it. So again, it doesn't need to be thick. 22 gauge would be absolutely fine, as it's just activating a relay. Number 3 is yellow with a green tracer. Now that is temp. And what I'll do is when we go through the layout, you'll see when I get to the temp over there, there is a loose wire there, so you guys can fit your own temperature sensor for whatever gauge you want. And obviously we bring it out here so that you can take it inside the vehicle to your gauge. So you don't have to have another wire sort of going into the engine bay, over the engine, etc. Number 4 is your gray, and that's your gray 14 gauge. That controls your fuel pump, all right? So again, it is controlled via a relay in there. That is perfectly capable of running a normal fuel pump, as long as it's under sort of 20 amps, which yeah, usually are. But if you do decide that you want to run a much higher fuel pump, you can also use that as a trigger for a relay at the fuel pump itself, okay? That is controlled via the ECU. So what I'll do now is I'm going to put a link up, or in all the links that I put up there, I do a nice video explaining exactly how the fuel pump systems work. So things like the major things is it doesn't prime. So a lot of times we get questions of, I plugged everything in, but it's not priming. Perfectly normal. Watch the video. I explain exactly how the fuel systems work, so you have a really good understanding of exactly when the fuel pump should run. Okay. And number 5 is yellow with a red tracer, and that is your check engine light. In this case, we've got it hooked up to our clocks over here, so we can see that it is actually working. So again, you'll see that there. We also have an LED inside the fuse box, and that is for the check engine light. So it's before you guys, if you guys want to get it either on the bench like I have here, or in the car and you haven't wired anything out yet, you can still see the check engine light and make sure that the system and the ECU is turning on when you supply ignition 12 volts. Okay. Then we have number 6, which is yellow, and that is your tacho signal. So in other words, it's the rev counter signal. The ECU is giving out the signal, and it is a 4-cylinder signal. So just bear that in mind. If you have clocks that require an 8-cylinder signal, you're going to need to convert that, vice versa, same with a 6, etc., etc. Okay. Then number 7 is a black with a red tracer. Now that is your ignition feed. Now the only thing that I would say there is just be careful if you are using a key barrel, and I have seen it in the past, where if you have a key barrel, you have accessory, ignition, and start. Now the problem with that is if you connect that up to accessory, when you turn over to start, the way that they work is they cut power to accessory and only ignition has 12 volts. So if you connect it to accessory and you go to start it, it's going to shut the ECU down and it's not going to start. Okay, so just make sure that when you are looking for an ignition, if you're just looking for it with a multimeter, make sure that ignition 12 volts from your key barrel stays live when you move it to the start position. Now then, if you're running a start button with a little sort of flick for ignition switch, obviously you don't need to worry about that because that's not going to be the case, but mostly with guys using ignition barrel. So just bear that in mind. Number 8 is a pink with a blue tracer, and that is your alternator light. Okay, so in this case it gives out a ground. So if you are going to use an LED as an alternator or charge light, remember that our wire goes to the negative side of the LED, 12 volts ignition to the positive side of the LED. One word of warning in relation to that: if it is an older vehicle that you're putting it into, and specifically a dash that has an incandescent bulb in it, do remember that these were designed to have the alternator light fed to the ECU, then communicated via MPX to the car, right? So what does that mean? If you have an incandescent light bulb, it can backfeed into the system, okay? So if you are going to use that and you're not going to upgrade the bulb from an incandescent to an LED, you must fit a diode so that it doesn't backfeed through that alternator charge light signal. If it does, worst case scenario, it backfeeds into the fuse box and keeps everything alive. Worst, minor case scenario, it'll keep the alternator alive, and then usually they burn out in a very short amount of time, anything from 3 to 6 months. Okay, so Please bear that in mind if you are doing that. So like I said, if you're using an LED light, it's not a problem because the LED is a diode. If you're not, fit a diode or replace the light in your dash with an LED rather than an incandescent bulb. Okay. Then last on the list, number 9 is yellow with a black tracer, and that is oil pressure. So that is your oil pressure switch. Again, exactly the same as the check engine light and the alternator light. The oil light gives out a ground. So again, if you're using an LED as an oil light, our wire goes to the negative side, 12 volts ignition to the positive side of the LED. Okay, if you're using a dash, usually they are automatically set up like that. So you could just connect straight to your dash and it will work. All right, so that is your 9-pin plug. That's pretty much all that you have to connect. In reality, permanent 12 volts, fuel pump, ignition, start signal, she will run. And that's pretty much all we're connecting over here. So 4 wires and she will run. Okay, so if you want to start on a bench, that's easy as that. Okay, so now we've done the connectors. What we're going to do is we're going to start moving our way down. But before I do that, obviously your one little plug that's coming out here, that is for your accelerator pedal. So again, we do put that on a separate connector. It is a nice 2-meter long harness that is going up to the pedal over there. So you've got plenty of room to tuck it up on the firewall and then back over there. And then if you do need to remove the ECU and the harness for whatever reason, you can just unplug it there. You don't have to remove all the wiring that you fitted onto the firewall. Okay, so that's all that side with the plugs. Moving along over here, you're going to see that we have got our little grommet. Now in this case, you can see we've already pre-put some heat shrink in there. We do like to keep it loose because obviously not every vehicle is the same and you guys are going to cut your own holes, etc. So we allow you to move this grommet to wherever it's most suitable for your particular application. Once you have it all nicely in, grab a heat gun, heat that down. It's a glue-lined heat shrink and that will then seal up the harness over there so no water comes through. Okay. Coming up along there, we're then going to get to our molded T-piece over here, and that's where the harness is going to split off, one way going that way, one way going that way. What I'm going to do now is as I'm on this side, we're going to go this way, work our way down to the front, then I'll come back here and carry on over there. So, first section that comes out this way is going to be ignition 7. So remember, with these UZ engines, it is 1, 3, 5, and 7, 2, 4, 6, and 8. And obviously you always look from the back of the engine. So that is the right bank, that is the left bank. Now remember, underneath here, if you wait till the end, you're going to see the photographs of what it looks like. We obviously have completely rebuilt the starter and knock section underneath there. They are all labeled. They're labeled knock 1 and knock 2. So remember, this is bank 1, that is bank 2. So when you get underneath there, Jonathan, to fit that, knock 1 goes on this side, knock 2 goes on that side. Okay, right, so moving along from there, harness is going to come up along here and it's going to break out at another section over here. It's going to break out to your cam sensor on your left bank, which goes right in the middle over there. It's also going to break out for ignition 5 and ignition 3. Okay, carrying on moving along here, it's going to break out again and that's going to go to ignition 1 over there. It's going to go to your oil control valve for the VVT-i on your left bank over there. And then at that breakout, it's still going to run along here and it's going to also go to your cam sensor at the front. Now do remember there is a little mounting point or a little metal flange over here that you can mount the harness to and clip it down over there. Coming down the front here, you're going to see you've got 2 holes there, and that is where the harness is meant to clip in. Usually you have these. Obviously you can still buy them from Toyota if you don't. Okay, but that goes over there. Once it comes around there, it's going to split up into 3 sections or 3 branches, should I say, when it comes down here. It's going to go through this hole on the top over here. And the first one that breaks off is going to be your Lambda sensor. Okay, so on the usual standard harnesses, it came down through the exhaust at the back there, but obviously it brought it very close to the exhaust and all the heat. So we've brought it down the front here, so you keep it away from the exhaust, away from the heat. And obviously the connector will last a lot longer because it used to be literally between the exhaust and the block over there and experiencing a lot of heat. And obviously there's usually a metal heat shield there, but a lot of you guys, when you're doing your swaps, that seems to find its way into the bin and doesn't go back on there. So again, that's another bonus on that one. The second one that breaks out there, again, straight through the hole over there, straight down through there, and then it's going to go to your crank sensor over there. So again, everything is labeled for you guys, so you shouldn't have any issues putting it on. Then the last one is a little tiny wire that comes through there, and it's going to go to your oil pressure switch. All right, so again, if you have an LS430, your oil filter sits like this. If you have a GS430 or a SC430, your oil filter sits like that. And obviously the way that this is designed, it'll work for either one because it breaks off right at the top here, so you can run it down through the back here into there. Okay, so that's this side completely done. Relatively straightforward, not much going on there. So let's go back over to the molded T-piece over here. Right, so coming out this side over here, what have we got? We've got two grounds. Obviously, one is the main one for your harness. The other one is for the coils on this bank over here. Okay, then we come across the first of our modular sections, and this is your injector and ACIS section over here. So this can obviously be tucked away. Obviously, I've just got it out so I can actually show you where it all goes, but this can be tucked away nice and neatly down in the bottom here. Your next section is your sub harness. I call it the sub because it goes underneath. And that's your starter and knock. And do bearing in mind that as per most of our new build harnesses, this does have twin core shielded cable for both knock sensors. So although in this particular case with the standard ECU, we're just using the narrow band single wire knock sensors, if Jonathon, the customer, wanted to upgrade to an aftermarket ECU, obviously we can then fit Bosch wideband sensors in there, okay? So again, it's just a feature we add in so you guys can upgrade it at a later day without having to obviously buy an entire new harness again, all right? Same thing with the injectors. Obviously the injectors go underneath. I do have a video on how to install that, Jonathon, so do give that a watch. It goes into great detail of exactly how you install that, but basically it goes through the middle here, clips on a bolt underneath there, plugs into the ACIS valve, vacuum solenoid valve that sits at the front here, and then all your injectors pop out here and clip in over there, okay? And the same thing on the other side, so you see all the injectors come out there. So again, the idea is that you can just unclip this one thing at the back, pull the whole intake manifold off, and obviously you don't have to unclip any of your injectors, which is the biggest killer of these connectors, is keep on pulling them on and off and on and off and on and off, and eventually the clips break. Okay, so that's to try and lengthen them as much as we possibly can for you guys by having to just move one connector to pull the whole inlet manifold off. We've also actually sub-harnessed the throttle. Now that's for two reasons. One, so you can then just unplug the entire throttle and take it off with one plug. Number two is obviously you are capable of running different types of throttles. And in the event of going aftermarket management and you wanted to fit a bigger throttle on here if you wanted to, again, you're not restricted. You can just phone us up and buy another harness for whatever throttle you wanted to fit in there. All the wiring is already there and easily changeable, okay? Right, so those are the sections that go underneath there. What I'm gonna do now is I'm gonna scoot over to the other side, and then that's gonna allow me to carry on going along there. Right, so popping on the back here, it's going to run its way all the way along here where it's going to break out here at the back. You're then going to have another ground over there. So remember the 3UZ used these two M6 holes at the top. You will see that there are other holes in the bottom. Same on the other side there and there. Obviously the 1UZs use these ones over, 1UZ VVT-i use these ones over here. The 3UZs use these ones at the top, okay? So you can see we've screwed it into the top there to show you exactly where it goes. Same on the other side, M6 bolts, in you go. All right, when it breaks out here, it's going to go to ignition 8. Okay, so that's your coil number 8. It's then going to scoot along here, break out towards the middle, and that's going to go to your cam sensor for your right bank. So remember, there's 3 cam sensors on a 1UZ VVT-i and a 3UZ VVT-i, one on each inlet cam to measure the VVT-i angle, and one at the front for fully sequential ignition and injection. Okay. It's also going to break out to ignition 6 and ignition 4. So those two come out there. Again, all nice and neatly labeled so you can't mix them up. Coming further to the front here, it's going to break out again, and we're going to have quite a few sections coming out here. So I'm going to start with the first one, and that is your throttle. Okay, so that's nice in there, and there's your plug to plug the whole throttle body off in one go. We then have your coolant temp sensor over there. You'll see you guys won't have a temp sensor in here, but this is just an old Toyota 1UZ non-VVT-i single wire temp sensor that I fitted in here. Obviously, depending on your dash or whatever instrumentation you're going to use to measure water temperature, this is quite a good spot to get that temperature reading from. You just have to fit your own sensor in there, okay? This is the temp wire that I was talking about. So again, it is labeled temp. We've left it loose with plenty of length there so you guys can trim it back, strip it, and put whatever terminal or terminals required to then fit to your own temp sensor over there. Right, next up we've got the oil control valve for the right bank. So that is over there. Then we've got ignition 2 coming out over there. And then lastly, I think for this section is going to be the MAF. Right, which is a really nice and long section, obviously, because you guys do your own pipe work. Want to make sure you've got plenty of length there to fit the MAF wherever you need to make it look the best. Right, so then the harness is going to carry on down here. We're going to break off over here and we're going to get to our alternator sub harness over there, okay? And also coming down along here, you've got your other Lambda sensors. Remember, we're just running the two main Lambdas that go in the exhaust manifold, not the secondary ones. Those are mapped out of the ECU, okay? Do also remember with the 3UZ, you'll see this one on the right bank has a long wire on the Lambda sensor. On the other side, it has a short wire. The wiring is different for these two, so you cannot just buy two of the long ones and fit them on. You do need to make sure you get the correct one between the left and the right bank. Otherwise, if you want to, you can obviously change the wiring. It's completely up to you, but just to be sure that you guys are aware of that. Okay, coming back to the alternator, obviously the reason we've sub-harnessed this off is because if you've seen Calvin's recent video, you'll know that there's plenty of alternators that you can fit on here. The newer ones on the 6 speeds are coming with the square 4-pin plug. But again, as long as you stick to either the European or the US LS430, GS430, funnily enough, the SC430 all the way up to 2010 still retained this oval plug. But again, if it's easier to find one of those where you are, phone us up. We'll make you a little sub harness for the 4-pin plug bolted in there. Just be careful of the JDM ones, especially from the crown. They do use all 4 wires and they are not interchangeable because they do require control from the ECU. So do bear that in mind, guys. And what I might do is I might put a link up to Calvin's video about the alternator, so you also have a much better idea of what goes on there. Right, so that is this entire section done of the layout. So hopefully, Jonathon, that's going to be really nice and easy for you to go through, drop it on, and there it is, nice and simple. It's just a U shape. You drop it straight on, you plug everything in, everything is labeled. Just bearing in mind, as part of the installation, you're going to have to pull the intake manifold off. You've got to fit that sub harness section to the knock and that, and you also have to fit the injector section to underneath the manifold as well. So make sure that's there. That is also a really good time to check that that ACIS valve is working, okay? So you can just apply it with a 12 volt in the ground. You should hear it click, okay? It is polarity sensitive, so if you don't hear it click doing it one way, swap it around the other way and make sure it clicks. If it doesn't click, it's much easier to change it with the inlet manifold off than obviously trying to do it, pull it off all again when you first start it up and realize that the ACIS valve doesn't close. All right. Okay, so that's the complete layout again. Right, so Jonathon, really nice and simple. What we're going to do now is we're going to move over into the actual testing of the harness. First off, just with the ignition on, and then with the actual thing running. So I'm going to get that set up now, and we're back in a second. Cheers. Right, so we've gone through the whole layout of the harness now. So what we're going to do is move into the testing. Right, so we're going to have 2 major sections. One is going to be just with the ignition on, carry out a few tests with that, and then we're going to do with the engine actually running. So what are we doing? On the ignition side, we're just going to be checking the check engine light. So we do have the check engine light in the fuse box. Also got it hooked up to our dash over there, so we'll see that light coming on as well. Oil pressure light, got a little LED down here. So obviously that is showing us the oil pressure switch light. The reason it's on at the moment is it is getting a permanent 12 volt supply from the fuse box, the outside part of the fuse box. Obviously the oil pressure switch is giving a permanent ground, so that light is on. When we start the engine up, you'll see that will go off along with the alternator light. Do remember that is giving off a ground as discussed previously, so that's how you need to connect that. Then the alternator light, well, that's a little LED right next to it over there, so that's going to come on as soon as I turn the ignition on as well. OBD2, so we're just going to go over to our machine over here that's plugged into the harness to make sure that it's picking up the right ECU, to make sure we can see live data and all of that good stuff with the diagnostic machine. Fuel pump, I'm going to use my machine to test the fuel pump. So what I'm going to do is go into active test, activate the fuel pump, and as discussed, I did put a link up previously about how the fuel pump systems work. So the ECU is controlling the fuel pump here, so that tells me that everything is wired correctly and it is working as we expect it to. Moving on to the actual starting part now, nice and simple. First thing we're testing is the starter, so to make sure when I touch the black with the yellow tracer wire to 12 volts, that the relay clicks, the starter motor turns over and the engine fires. Okay, so we know the whole starter circuit is working exactly as it should do. Then the ACIS, so that's this little valve down here. Now what I will do is, again, I'll put a link up there. I've done a nice in-depth video on the ACIS system, or acoustic control induction system. All right, variable intake if you want to call it that. But that video goes through everything, how it works, what it does, and what it looks like underneath there. Okay, for this purposes, obviously we're just looking to see that the valve closes like that. Okay, so that's what we're looking for there. Tack, we're going to come over to our clocks over here. So I have connected my yellow tack wire to the cluster here, so we'll see the rev counter actually show an indication on there. We know that's working as it should do. Coolant temp, in this case, unfortunately, I did run out of those little MPX boxes. I think I previously said that. So basically what we'll do is you're gonna have to rely on the fact that I've just used a multimeter to check from there to there. So I do apologize about that. We'll have those back in stock soon. And obviously we'll be going back to the testing the other way. Drive-by-wire, so again, we're just going to press the pedal like that. Again, this is a full drive-by-wire system, not like the earlier 3UZ VVT-is where it was sort of a hybrid. You had an accelerator cable that still went to the motor. In this case, no accelerator cable, just electronic throttle. So as soon as I touch that pedal, the engine should rev up and I know that everything is working as it should do. VVT-i solenoid, so we're using the OBD2 machine here, and what we're doing is we're testing each oil control valve on each bank, and what it'll do is advance and retard the cam, so it'll sound like a lumpy cammed engine. So when I do that, you should hear that engine note change, and that indicates that both the oil control valves are working as we expect them to. Then injectors and coils, obviously I've grouped them together, and the reason being is that I go and pull out each injector one by one, and you'll see the engine or hear the engine misfiring. So I know that each cylinder is firing exactly as it should do. Now the reason I pull the injectors out is because on the 3UZ system, if you pull the coil out and the ECU picks up a misfire, it shuts down the injector and it won't turn it back on again until you do an ignition off and ignition on again. Okay, so if I pull the coil plugs out one by one, eventually it would try and fire on one cylinder as I got to the last one over there. Okay, now furthermore, I obviously haven't actually pushed and clicked the injectors in. They do have new terminals, and those they rely on pressure force to stay in. Just pressing them on like that is enough to keep it running, but obviously single-handedly, if I had to try and unclip all of them, it would be a real pain. So if I do start it up and one cylinder is misfiring, you'll see me just go along and try and push these injectors down to make sure it is like that. So obviously I have run it already, so we should be fine, but just if that does happen, that's what I'm doing. Okay, and last thing we're going to do is the codes. So we're going to go on the machine, and as discussed, the ECU is fully remapped. So all the automatic gearbox codes are gone, the secondary Lambda codes are gone, EVAP codes are gone, all of that stuff is gone, so we'll have 0 codes on the system, so the diagnostic system will work completely as standard. If you have codes, you have problems that need to be resolved, okay? If everything's fine, 0 codes. Right, so let's get into the first part. So what I'm going to do, I'm going to turn the ignition on, which is basically connecting this black with a red tracer wire to 12 volts. So I'm just going to do that, and as I do, you'll hear the relays click, and most importantly, you'll see that check engine light come on the fuse box there. Right, there you go. So that's got power now. We've got our LED on in the fuse box, so we've got our check engine light, and to confirm that, there's our check engine light on our cluster over there. So we know the yellow with the red wire is working exactly as we expect it to. Oil pressure light, well, we already know that was on, but now we can see the alternator light on as well, and obviously when we come to start it, those two will go out, indicating that they are working as we expect it to. OBD2 machine, right, so these do take an absolute age to load up, so I have already loaded up, but I'm going to go into function, going to go into system select, and what you will see as soon as I go into there, give it a second, there you go, LS430, right, so we know it's picking up all the correct in ECU. I'm going to go to the data list now, so you can actually see all the live data, and as you will see there, as it loads up, there you go, we've got 20 degrees on the coolant temp, 19 on the air temp, 15% on the throttle, so we're getting actual live data through, so we know that that's all good. Okay, so fuel pump, as I said, we're going to go into active test over here. Right, and as we get there, you'll see it's fuel pump relay and fuel pump, but confusing, not confusing if you've watched the video that I linked up there, that explains exactly what is going on there. So we're going to test the fuel pump for now. And I'm just going to press that arrow. I'm going to keep quiet now so you can hear the relay click and the pump start running. Okay. All right, and you can hear the pump going crazy there. Right, okay, so that's fantastic. So we know the ECU is controlling that, and we know all the wiring is correct there. Okay. Right, so what I'm going to do now is I'm just going to start it up. I'm going to get the engine nice and warm, so that we can see the data on there, so we see the coolant temp is working exactly as it should. So let me do that, and we'll be back in a second with you guys, okay? Right, so back again for the testing part now. I've obviously run the engine. The astute among you will notice that it is the next day. Do apologize, I didn't realize it was 2:30 in the morning when I wanted to start the engine last night. So I'm back now this morning to do that, carry on with the rest of it. So in terms of the testing with the engine running, it's nice and simple. We're just going to be testing the starter circuit. So I'm just going to touch the black with the yellow wire on 12 volts and the engine will crank over and start. Then we are going to look at the ACIS. So again, we're going to check that this little valve closes down as soon as she starts up. Then we're going to check the tach. So we're going to make sure we've got a tacho signal coming through on the cluster there. Okay, and then we're going to look at the drive-by-wire. So I'm just going to, again, press the pedal so that she revs up and we know that's all working. VVT-i solenoids, we're going to use our machine just to test the VVT-i solenoids one bank at a time, and you'll hear the engine run lumpy as soon as I do that. Then we're going to move over to the injectors and coils. So basically what I'm going to do is pull the coils off one by one. You're going to see each cylinder misfire as I do that, and that's going to show us that every single cylinder is firing exactly as it should do. And as we know, this engine is fully sequential fuel and ignition, so if they all misfire when I disconnect it, we know everything is correct and as it should be. Okay, then lastly we're going to come back and we are going to do the codes, so show you that there are no codes on the engine itself, on the ECU itself, and that therefore if you do have codes, Jonathan, then there is an issue that you do need to resolve. Right, so first thing I'm going to do is put on my ear defenders. We'll put the ignition on and then we'll go to crank her over, so bear with me a second. Alright, so let's get the ignition on. Right, so now you can see we've got our both lights on. I'll do a quick squiz over that to show you that they are turning off when it starts. So let's just get it started. So 1, 2, 3. As you can see, the light's gone off there, the light's gone off there, the light's gone off there. Right? See that this has gone down, so we're happy with that. You can see that we've got the tach signal on the dash there. Okay, okay, so that's working all as it should. Right, let's move on to the drive-by-wire. So we're just gonna. Right, so that's all gravy. VVT-i solenoids. So we're just going to come over to our machine over here. We go to active test mode. VVT-i control bank 1. Enter. And as we do, there you go. Alright, let's go to bank 2. Right, okay, so that's the VVT-i solenoids done. Let's move over to all the injectors now. So one by one, I'm just going to pull them out. So it's number 7, number 5, number 3, number 1. Right, let's move over to the other side quickly. Okay, so we've got number 8, number 6, number 4, and finally number 2. Alright, so there you go. Okay, so all of those are firing exactly as they are, and we'll just go over to trouble code this now quickly. You can see there we've got 0 codes at all. And then obviously it's picked up a misfire where we've been removing the injectors from there. Alrighty. Okay, so what I'm going to do now is kill it off. Fantastic. Okay, right, so everything tests out okay. Drive-by-wire works. All the instrumentation things work. Obviously engine's running and running smoothly. All cylinders are firing as they should. Obviously we've got 0 codes related to the automatic gearbox. We've got 0 codes related to obviously the secondary lambdas and all that type of jazz. You can see it is picking up that we're misfiring. Obviously I've been pulling all the injectors off there, so it's picking up that we're misfiring on those cylinders. So it's doing exactly what we expect it to do. So just remember, you can see the check engine light is not on when she runs. So again, if the check engine light does come on, Jonathan, is a problem that you need to get resolved. Obviously, you're going to need diagnostic equipment like this to carry out the code reading. Okay, unfortunately, we can't do the flash code system like we do with the 1UZ VVT-Is and the non-VVT-Is with the 3UZs on the European, Australian, obviously in this case, and the American ones. JDM ones you can on the 3UZ, but that's the only ones that you can do that. So for the rest of us in the world, we need a diagnostic machine to carry that out. Right, so Jonathan, hopefully that's been helpful. Hopefully the layout and everything is going to help you to get everything on and dusted. At the end now, we're going to put all the pictures of what it looks like complete. Obviously, we put the build photos at the beginning. once it's complete, and also what it looks like underneath the intake, so you can see how that start and knock harness is fitted onto the engine there for you. Right, but for everyone else, thanks for watching. If you do have any questions, please put down below in the comments. I'll get to them as soon as I can. You can also find us on Facebook at Phoenix Engine Management, and you can ask us any questions that you'd like there. Jonathan, let's get this all boxed up, get it back to you in Australia. And for everyone else, thanks for watching. We'll see you again.
How much I miss not knowing that we're all screwed when we play our roles and ignore the problems. I wish I knew how much I miss not knowing that we're all screwed. I wish I knew.